Hello and welcome to UTA's Department of Electrical Engineering Solder 3 training. Here's what you'll use when you take the training. A custom UTA SMT printed circuit board, a solder paste stencil from OSH, it was $25 for the metal one, a set of very fine tweezers with an electrostatic discharge coating on them, a black stick to stir and place the solder paste, some perf boards of the same thickness as the PCB, some masking tape, a squeegee to spread the solder paste, and of course some solder paste. Let's take a closer look at the solder paste. It's a mixture of thousands of small metal balls and no clean flux. Start by placing the PCB on a flat, stable surface. Use the perf boards to secure it to the surface with the masking tape. Carefully remove the stencil. Its edges are very sharp. Also be careful not to bend it. Notice the stencil is marked on one side, indicating the top of the stencil. Line up the holes in the stencil with the pads on the PCB, then tape the stencil down. The solder paste we are using was purchased from Mauser for about $55. It's made up of 96.5% tin, 3% silver, and 0.5% copper. The melting point is listed as 423 to 428 degrees Fahrenheit. If kept in a refrigerator at 40 degrees Fahrenheit, it should last around a year. First, we must let the solder paste warm up for 4 hours before we use it. We'll inspect the paste for clumps and debris and remove any. Then we'll stir it for a smooth consistency. Spread a thick line on the side of the stencil that is wider than the holes in the stencil. Put any remaining solder back in the jar. Seal the jar. Now we're ready to apply the solder paste. This is similar to silk screening a t-shirt. Rake the squeegee and paste across the stencil openings. Notice the solder did not completely fill all the holes in the stencil. With the solder still on the squeegee, we'll rake across the stencil in another direction. Once the holes in the stencil are filled, give one last good rake to get as much solder on the squeegee as possible. We'll put the extra paste back in the jar. Seal the jar and refrigerate after you're done with the PCB. Very carefully remove the stencil without disturbing the solder paste on the PCB pads. You can clean up the stencil, squeegee, and stick with isopropyl alcohol. Whatever you do, do not touch the wet solder paste on the PCB pads. Now let's look at the components we'll use. The LEDs come in a tape and reel package. Carefully remove the tape and dump the LEDs out. From here on, you do not want to sneeze. The green rectangles indicate the cathode. Place the LED over the pads and gently press it into the solder paste. Try not to smear the paste like I just did. Install the second LED in the same manner. Now we'll install the two 100 ohm resistors. Again, they come in tape and reels, so placement machines can populate a PCB rapidly. Place the resistors in the same manner as the LEDs. Refer to the board layout and schematics to place R1, R2, C1, and C2 in the same manner. Now we'll place the 555 timer. The line on the chip indicates the bottom right of the chip is pin 1. Gently place the chip into the solder paste. Try not to smear it like I just did. You will see later that SMT is very forgiving. Place the coin cell battery holder as shown. Carefully move the PCB onto the opening in the reflow machine. Be sure not to touch the wet solder. Turn the switch to hot and move the upper and lower heat exchangers above and below the PCB. We will try to follow the recommended heat profile for this solder paste. When the solder melts, you will see it become very shiny. Notice the parts are a little crooked too. Let's fast forward to the melting point and observe the cool thing about SMT. Notice that the solder around the via holes has just melted. The via holes basically connect the top of the board to the bottom of the board. Keep a close eye on the 555 timer. Notice that there seems to be way too much solder. It's starting to reflow. And right now, you can see it just moved straight into place and lined up perfectly. SMT parts have a tendency to self-align. At this point, it looks like all of our parts have reflowed. So what we're going to do is we're going to turn the heat off of the reflow machine and turn it on cool and allow cool air to blow over the PCB to help cool it off rapidly. Once it's cooled off, take it out and inspect it for any solder bridges. If everything looks good, install your coin cell battery and check your circuit.